And before we go to some brief exercises that review what we've done before and extend it a little to different directions, we now undertake our most difficult formula. Namely, remember with the social network exercise, we had zeros and ones marking whether a person knows the other or not. John on the third row knowing Jill on the second column, and Jill on the second row knowing John on the third column. Okay, so what we did was we transposed this matrix, which meant, and if you haven't seen this video, it's good to view this first. So we transposed this matrix, which means that the first row in the initial table became the first column in the second table, which in turn meant that what had been John knows Jill in the upper table, this same lower table had it at the same place Jill knows John, really, because rows and columns had switched places. And now what was done was these two tables were subtracted from each other, and like for instance this upper table minus lower table. And since everything had to end up as zeros, we would have had all the people knowing each other like reciprocally. Instead, we had two ones, as John didn't know. John didn't know Hillary, but Hillary, if we take a longer look here, and more specifically, Hillary knew of John. So here it was. So we knew that all the relationships were not symmetric, and we could also see it from the graph, where we had between 2 and 8, we had arrow, which went from 8 to 2, but not from 2 to 8. There is no arrow in here in this end. Okay, and now it turns out that there is again no need for these intermediary tables, that all this symmetricity can be checked with one formula, and it goes like this: equals. And so far, when we looked at more difficult applications of sum product, like those cars, whether they were manufactured late or early, then the actual thing was that these calculations that we have done so far could actually have been done with SUMIFs as well. The SUMIFs formula, which had some really similar applications. But now, this formula is really unique to sum product only. It's a complex sum product array formula. Equals sum product, and now double parentheses, and now we take the initial table and we start comparing it, which means that we press smaller, bigger, and now we want to compare it with the same original table transposed, which means that we write in here transpose and take the same upper table. Okay, now as we transpose, remember, transpose is an array formula. So here forward, we need to press Ctrl-Shift-Enter for this. Not because of the sum product, but because of the transpose. Okay, now transpose transposes, then the comparisons smaller, bigger does comparing, and we will get those ones and zeros, or trues and falses, which means that if everything is, let's say, reciprocal or reciprocal as we said, it's actually going to be all zeros. But we already know from the data that information is not really symmetric. So what we need to do now is close these parentheses as well and multiply these trues and falses, or ones and zeros, by 1. This is actually a bit of a exception to the rule. Usually we considered, if something was being compared, we considered these truths and falses to be either truths and falses or ones and zeros, which means that we shouldn't multiply it with anything. We should just be able to write some product and get the number of differences. But it turns out that if we don't multiply it with anything, these are more like truths and falses. These are not yet ones and zeros. If we already multiply, then they turn into ones and zeros nicely. But right now they're still truths and falses. Thus, in the end of the formula, we have to write the times 1. So it multiplies those truths and falses nicely and gets ones and zeros out of them, or them into ones and zeros. And now we press Ctrl-Shift-Enter, and voila, we get 2, which stands for these two differences that are between the table and the transposed version of the table. We could take this formula and just press Enter. Now transpose doesn't work nicely because it's an array formula and we needed Ctrl-Shift-Enter. So thus we have to go back and press Ctrl-Shift-Enter to get the number 2. So this is really a complex formula. It's some product that compares, it transposes within itself, and then these truths and falses don't turn into ones and zeros at one step, but have to be multiplied by ones so that they would. So it's really complicated, but as we see, such formulas can also be used in Microsoft Excel. And now it's all downhill from here.